Hello and welcome back to Jill's Bench. My name is Greg Perugini, and this lab we're going to talk about watts and thermodynamics. So we all know that if we leave a cup of coffee out at room temperature, it will cool off. It's dissipating the heat into air, and it's a proof of the second law of thermodynamics, that heat will always go to cold. I'd have to force heat out to make for cold, but the natural process is heat to go to cold. A system will reach equilibrium by the heat moving towards that cooler area. What we're going to do is measure the rate that your microwave transfers energy to your food. And the rate of transfer of energy is called a watt. A watt is joules per second. And we're going to use a cup of water to measure that. Now, we give you a cup with this, and you'll need your microwave, but we're going to find the watt output of your microwave to the water. To do that, we're going to need a few pieces of information. We're going to need the amount of water in the cup. We need the specific heat of water, the amount of time it's heated, and the temperature before and after. So, we're going to fill up the cup to just that level that you see on this sheet here, right, on this slide. When we fill it up to about that, that's about 250 grams. So I have water in there for that amount. So, I do have that. That's the first thing we needed. The second is the specific heat of water. That is a known quantity, 4.186 joules per grams Celsius degree. So we know that. That's the second piece of information we need. The third is the amount of time. And that's pretty easy to get to, because we can just take this thing and stick it in a microwave, right? So when we stick this in a microwave, we will cook it for 30 seconds. So we have to get the temperature before and after. With that, what I want you to do is after you put your lid on, you take the digital thermometer that comes in your kit. You can see it reads 23 degrees, and you want to put the probe right in the water. And just leave it sit there until you get that temperature correct. So you know the temperature of the water. Then what you do is you take the probe out, and stick it without the probe, just the cup with the water in the microwave, and you do it at high for 30 seconds. Then you bring it out, and you get the temperature of it, again, the same way. Okay? So that will give you measuring the temperature before heating and immediately after heating. Well, using that, again, the amount of energy that we're supplying, the mass in grams, specific heat, the change in temperature, we can arrive at the amount of energy we're supplying, because we know this, we know this, we know the mass is 250 grams, we know 4.186, we know the change in temperature because we just measured it, the temperature before and temperature after. That's going to give us the amount of energy that we put into the system. Once we have the amount of energy we put into this system, the cup, and we know we did it for 30 seconds, that gives us joules per second, or the watts. So, we're going to calculate the rate your microwave delivered energy to the cup of water. You want to do this in several trials. Using that, you should be able to predict the temperature if you cooked it for 60 seconds. And you should be able to calculate how many seconds it would take to bring that cup of water from room temperature to boiling at 100 degrees Celsius. And answer all the other questions from the lab. And good luck.